Good morning, class. Today we're diving into the captivating world of gravitational force. Picture this. You're sitting under a tree, an apple hanging above your head. Suddenly, it falls. But why does it fall towards the Earth? That, my friends, is the gravitational force in action. Newton's law of universal gravitation tells us that every particle of matter in the universe attracts every other particle with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This law, formulated by Sir Isaac Newton in 1687, is one of the fundamental principles of physics. It explains why objects fall to the ground, why planets orbit the sun, and why the moon stays in orbit around the Earth. The law of universal gravitation can be expressed mathematically as F equals sign gm2, r squared, where F is the gravitational force between two objects, G is the gravitational constant, m1 and m2 are the masses of the two objects, and r is the distance between their centers. This equation shows that the force of gravity between two objects is directly proportional to the product of their masses, and inversely proportional to the square of the distance between them. For example, if you double the mass of one object, the gravitational force between it and another object will also double. If you double the distance between the two objects, the gravitational force will decrease by a factor of 4. This means that the force of gravity gets weaker as the distance between two objects increases. It also means that larger objects exert a stronger gravitational force than smaller objects. The law of universal gravitation applies to all objects in the universe, from the smallest particles to the largest galaxies. It is a fundamental principle that helps us understand the behavior of the universe. In conclusion, Newton's law of universal gravitation is a fundamental principle of physics that explains how objects are attracted to each other. It is a simple equation that has profound implications for our understanding of the universe. Imagine two objects, say a planet and a satellite. The planet's gravitational pull keeps the satellite in orbit, like a dance between two cosmic partners. But it's not just planets and satellites, it's the reason we stay grounded, the reason tides ebb and flow. Gravity is a silent force, yet it shapes the very fabric of our universe. So the next time you witness an apple fall or marvel at the stars, remember, it's all thanks to the invisible force that governs the cosmos, the gravitational force. Thank you, class. Keep exploring, keep questioning, and embrace the wonder of gravity.